go. Today we are studying linear systems. A linear system is two or more lines where we identify their point of intersection. We look for the point of intersection. Okay? There are three types of linear systems. The first and the most common one is this type of linear system, where you have two equations and you're finding an intersection point. In that situation, you come up with an answer. For example, you'd get, like, say, x is equal to 5, and when you plug it back in, you'd say get a coordinate of like 5, 3, or something like that. You come up with an answer that has a coordinate. However, you can have another type of system, and your other type of system might look like this. That's like what we talked about yesterday, right? There you have two lines that are parallel. Do they ever intersect? So therefore, you will come up with no solution. What does that look like algebraically when you're solving? It looks like this. You'll come up with an answer like 2 equals 7. Is 2 ever equal to 7? No, and that tells you that it's no solution. The third type of one that you could come up with is if you have a line and you have another line that sits right on top of that previous line. In essence, they are the same line, and so you have what we refer to as infinite solutions. Infinite solutions. When you solve, you'd get an answer like 7 equals 7. 7 is always equal to 7, so therefore, infinite number of solutions. Those are the three types of answers you can get. We also have three ways of solving these systems. The first one is going to happen via graphing. So I'm going to graph this line, and I'm going to graph this line, and be able to solve the system by finding the point of intersection. I can tell that it starts down at -2, and it has a slope of 1. Up 1 and over 1. And for the next line, in order to graph this one, I'm going to choose to place it into slope-intercept form. I'm going to subtract x from both sides to get 2y is equal to -x plus 6. As I divide by 2, I get y is equal to -1/2 x plus 3. I plot my 3, and as the slope is -1/2, I go down 1 and over 2, down 1 and over 2, down 1 and over 2. Does it look like those lines cross at a nice spot on your grid? Not really, right? That doesn't mean that they don't have a solution. It just means that we can't tell exactly what the solution is. So we just estimate. I'm going to estimate this to be 3.5 and 1.5. Notice how for the next one that they're not in slope-intercept form. I'm going to show you a little trick. You've done this before. This is to help you as we review for your test. Your test will be next week, Thursday. We'll get in a test on Thursday. We'll have our final assignment on Monday. We'll spend time preparing on Tuesday and Wednesday, test on Thursday. I'm going to find the x and y intercepts. You guys remember, in order to find the x-intercept, we plug in 0 for y. Suppose y was 0. What would x be? I have 2x is -4, so what is x?
-2.
Yeah. And then I go ahead and scratch that off, and now I go ahead and I make x 0. If x is 0, then y would be positive 4. Then we're going to move on down here, and we're going to move to our next piece. We have x and we have y. If we cross off our x, we could tell that y would be 7 and that x would be 7. So that tells us our x and y intercepts. We didn't put it into slope-intercept form. We're just going to graph those. X is -2. Y is 4. And for the next one, x is 7 and y is 7. Here it looks like they do cross at a nice spot. They cross at 1, 6. Anybody know what I could do to check to see if 1, 6 is correct? You could take 1, 6 and plug it into both of these. And if it works for both of them, then it is a solution to that equation. Okay. Flip it over. We got 2 more ways. We want to do these next 2, and then you guys can have time to work. We want to talk about substitution and elimination. So we have graphing, we have substitution, and elimination. Substitution we like to use when you see a variable that's solved for. So here you see x equals. So I'm going to take this thing that x is equal to, and I'm going to put it in for x right there.
I gotta go for soccer.
Have a good day, sir. Good luck.
Thank you.
Go get a victory. Y equals, I have my 5, I have my plus 1/2, and instead of writing x, I write 2y minus 10. I distribute my 1/2, and I get y minus 5. What do you notice? I get y equals y. That's an interesting answer. What do you think that means? You're correct that it's an interesting solution, but is it going to be the infinite solution or the no solution? If you get something equal to itself, that means it's an infinite solution. It means that it's simply one line on top of the other one. And so in this case, we say infinite solutions. For our next one, we see what y is equal to. So we're going to take it and drop it right in for y right there. See if you could go ahead and solve for the rest of it. Find that intersection by substitution. I distribute my -2. You should come up with -3x is equal to +3. Divide by -3, and we get x is equal to -1. Now that's not my answer, I need my y value as well. If you have x is -1, how do you find the y value? You plug it back in. 3 times -1 is -3, and -3 plus 2 is -1. And there we have our solution. The last thing that we want to discuss today about solving systems is by using elimination. Don't write this down, but with elimination, what we like to do is we like to add or subtract the two equations. Watch if I add these right now. I get a 13x, I get a -8y, and I get a 12. I didn't get the x's or the y's to go away. I would like them to get to go away, and so I can multiply through by a number to make something go away. Anybody know?
You can make the -4 into a +7.
Yeah, I multiply by a negative, and that's going to change the -4y into a +4y. So I end up with a -5x plus 4y is equal to 0. Now, as you add these together, 8x and -5x make -3x. -4y and +4y make 0, and 12 and 0 make 12. If I divide, I get x is equal to -4. Remember, you have to find the y value as well. So if I take that -4 and I plug it back in, and you can plug it back into any of the equations you have up here. I'm going to plug it back into this top one right here. And I get 5 times -4 is -20, minus 4y is equal to 0. So I add the 20, I get -4y is 20, so y is -5. So my coordinate is -4, -5. And finally, our last example is, notice that none of these numbers are the same. So that's where you get a choice. Nunu, do you want the x's to go away or the y's? It's up to you. You can't make a wrong choice.
The x.
She wants the x's to go away. Well, right now, both of them are positive, and one's a 4 and one's a 5. So I have to decide what number do they both multiply to. They multiply to 20. I'm going to make the bottom one a +20, and I'm going to make the top one a -20. So therefore, I have to multiply the top through by what? -5, and I multiply the bottom through by +4. And if I do that, I get -20x. I have a +15y equals -55. And on the bottom, I have a +20x minus 8y is equal to 48. Now what's really nice is I add them together. The x's go away. They eliminate. 15y and -8y make 7y. And -55 and 48 make -7. Therefore, y is equal to -1. We're not done. We have to take that -1 and drop it back in. So I have 4x plus 3. When I take -3 times -1, I get +3 is 11. So 4x is equal to 8. Or x is 2. And therefore my coordinate is 2, -1. So back in the day, you would have spent a day on graphing, probably 2 days on substitution, probably 2 days on elimination, a day on all of them. We just do one day and all of it in review right here. Something that you've seen before, but solving systems, again, something that we want to be able to do quite well as we move into our next type of class. Before you move to your homework, what I want you to do is decide for these three right here, just talk about substitution or elimination. Which method would you use for number 1? Which method would you use for number 2? And which method would you use for number 3? Go ahead, talk to the person next to you. Which method do you think would be most appropriate? Go.
First one, probably do substitution. If you mix them around.
You do substitution phase first and then.
The second one, you can do elimination.
I would definitely do substitution here.
And then this one, you can do elimination.
Whichever one you feel like.
If you fix this, you can do elimination.
What do you think about for number 1? I agree, because y is equal to something. Everybody agree there? For the last one, what would you use?
Elimination.
Yeah, and I think elimination is great. You see right now that you have the x and y stacked upon each other, don't you? So I think elimination is a great method there. The middle one's kind of tough to tell, isn't it? Kind of tough to tell. Might graph it. You might bring the 2x over, so it'll be like a negative 2x plus 3y is equal to negative 4, and then use elimination, right? I want to show you something kind of tricky, see if you guys can understand this. I'm going to take this one and divide through by 3. And when I do, I get y is equal to 2/3 x minus 4/3. And then this top one here, I'm going to solve for y. I'm going to have negative 12y equals negative 8x plus 48. And when I divide by negative 12, I get y is equal to, what does negative 8 over negative 12 simplify to? Two-thirds. And 48 divided by negative 12 is negative 4. What do you guys notice about those two lines? It's from yesterday. They are parallel, aren't they?
Yeah.
One has a slope of 2/3. This one has a slope of 2/3. But they have different y-intercepts. So if they're parallel and they have different y-intercepts, what would the solution be?
No solution.
No solution. So sometimes you don't even need to solve by substitution or elimination. Sometimes you could just tell by looking at it when it's in slope-intercept form as well. Yeah, kind of interesting. All right, that's it.